The night sky is lying to you. You look up and see dots, clean, tidy stars scattered across velvet black. But those dots are not the truth. They're the glow spilling from faraway furnaces, and they hide what really matters. Planets, uncountable, unnamed, unvisited. The cosmos is not a gallery of stars, it is an archipelago of worlds. Some are drowned beneath global oceans so deep that mountains would vanish without a ripple. Some are super-Earths, heavy, muscular planets with gravity that can bend your bones and crush your breath. Some are twilight worlds locked to their stars, a hemisphere that never sleeps, a hemisphere that never wakes. Some rain molten glass, some snow shards of methane. Some never see sunrise at all. Why? Because they belong to no star. We call them exoplanets. But that name is too small. These are alien worlds. And once you understand them, the solar system starts to feel like a local rumor. For most of human history, planets around other stars were guesses and prayers. Then, in the last 3 decades, the sky cracked open. We didn't see these worlds directly, we felt them. A star dims just a little on a perfect clockwork rhythm. That tiny eclipse is a planet crossing the star's face. The transit method, or the star wobbles, tugged by the planet's gravity. The radial velocity method. Sometimes starlight passes through a world's thin air on the way to us. Molecules sip a little of that light, leaving fingerprints, transmission spectroscopy. From those fingerprints we read chemistry, clouds, heat, winds, and maybe one day life. By now we've confirmed thousands of exoplanets, mini-Neptunes and hot Jupiters, super-Earths and sub-Saturns, worlds in clockwork chains where 6 planets share a narrow strip of stability, all clicking past one another like pearls on gears. The lesson is brutal and beautiful. Our solar system is not normal. It's just one way to build a sky. Picture a world where there are no continents, no shorelines, no harbors, no mountains. An ocean planet, water stacked in unimaginable volumes, perhaps hundreds of kilometers deep. Beneath that pressure, water stops behaving. It freezes without cold, turning into exotic ices, icy Fae and ice sever, solid phases that form under crushing weight. Above, the surface swells under hurricane winds and perpetual twilight storms, while the star paints a restless silver skin. Could life exist there? Maybe not the kind that builds radios, no dry land for fire, metallurgy, cities, but life that breathes oceans, that learns to harvest chemistry from alien suns. We can't rule it out. In fact, some astronomers think ocean worlds may be common, their water delivered by icy birthplaces and migration in the early chaos of a system's life. And there's a new whisper across the field. Hyken worlds, hot, hydrogen-blanketed water planets, where atmospheres might cradle biosignature gases. If nature is generous, their skies could carry hints of life's breath. Our solar system skipped this design. The galaxy did not. Super-Earths are planets bigger than Earth, but smaller than Neptune, rock-heavy, iron-rich, with gravities that can double or triple our own. Stand on one and your body complains. Your heart works harder. Your steps are short, deliberate. Mountains grow lower, erosion wins. The horizon feels closer, as if the world is leaning on you. But super-Earths may be engines of habitability, thicker atmospheres, stronger magnetic fields, long-lived tectonics that recycle carbon and keep climates stable. If life favors steady homes, super-Earths could be the galaxy's condos for biology. And yet there's a cliff in the data, the Radius Valley, where worlds seem to split into rocky super-Earths and mini-Neptunes with gas envelopes. The sky is telling us that planetary atmospheres live and die under their stars, and some worlds are stripped down to bone. Not all planets are invitations. Some skim so close to their stars that years last a day, their surfaces blazing at lava lake temperatures. Glass storms rage on others, flinging shards sideways at hurricane speeds. There are carbon worlds where diamond mountains may rise in endless night, sulfur skies, iron rain. And then there are the tidally locked worlds, one face in perpetual daylight, one in endless dark. the line between them a ribbon of eternal sunset called the Terminator. In that twilight ring, heat and cold might balance, deserts to one side, glaciers to the other, and a narrow habitable belt where winds howl from day to night forever. Would you build a city there? Streets glowing under a star that never sets? Ice mines trucking to the warm zone? Solar towers drinking constant daylight? An alien civilization might find such a world comfortable. Some worlds lose their stars entirely. Ripped free by gravitational arguments, they wander the galaxy as rogue planets, frozen, lightless, unmoored, hopeless. Not entirely. Beneath thick atmospheres and insulating clouds, with geothermal heat from formation and radioactive decay, a rogue planet could keep subsurface oceans liquid for billions of years. No sunrise, no seasons, no constellations, only the patient glow of interior heat. Life doesn't ask for beauty, it asks for energy and stability. A rogue planet might offer both. We used to think oxygen and water vapor would be enough. But planets cheat. Geology can mimic biology. Volcanoes can fake methane. Photochemistry can play tricks with ozone. So now we hunt combinations. Oxygen with methane out of balance, carbon dioxide with trace gases that shouldn't coexist, hazes and cloud decks that make no meteorological sense without biology stirring the pot beneath. This is forensic astronomy, crime scene science at light-year distances. We aren't just seeing worlds, we're cross-examining them. And the new witness has taken the stand. Space telescopes that can peel apart starlight with surgical precision. They're young instruments, but their verdicts will redraw our maps of what is possible. We are not tiptoeing up to a revelation. We are accelerating toward it. Every transit, every spectrum, every wobble is a letter in a word we are learning to read. Worlds. Worlds that make a liar of our old sky. Worlds that say Earth is special and also common. Worlds that tell us life may be rare and also inevitable. Tonight the stars will come out. They will look the same as yesterday. They will try to fool you again. Don't let them. Remember what they hide. Planets by the thousands waiting, not for our wonder, but for our arrival. When you imagine the birth of a planet, you probably picture something gentle. Dust swirling in calm circles, slowly knitting itself into worlds. That image is wrong. Planet formation isn't a ballet, it's a riot. Every star is born from a collapsing cloud of gas and dust. But when the star ignites, it doesn't clean up after itself. Around it remains a swirling disk, a maelstrom of debris, ice, rock, and metal, spinning at tens of thousands of kilometers per hour. Tiny grains bump, stick, collide, and grow. Centimeter-sized pebbles become boulders. Boulders merge into mountains. Mountains smash into continents. And from that endless wreckage, planets emerge. Not built but assembled through catastrophe. The early solar system was a shooting gallery. Impacts big enough to melt crusts were common. One such collision likely birthed our moon, Earth struck by a Mars-sized body called Theia. The universe doesn't hand out planets neatly. It forges them through fire and violence. When astronomers started detecting exoplanets, they expected to find systems like ours. Neat orbits, rocky worlds near the star, gas giants far out. Instead, the data spat back nightmares. Hot Jupiters, gas giants as big as Jupiter, orbiting their stars in days. So close they complete a year in less than a week, so hot their atmospheres boil. Their skies bleed metal, they shouldn't exist there. They couldn't have formed there. And so we learned that planets migrate. Massive worlds born in the cold outer reaches spiral inward, dragging dust and smaller worlds with them, rearranging entire solar systems. In some, the migration stops gracefully. In others, the inner planets are torn apart. Order gives way to destruction. If our Jupiter had done the same, Earth would never have formed. So every sunrise you've ever seen exists because our gas giant stayed in its lane. Plot every known exoplanet by size and you'll find a strange gap. Few planets fall between about 1.5 and 2 Earth radii. It's as if the universe draws a line between super-Earths and mini-Neptunes and erases everything in between. The reason? Atmospheric death. Small planets close to their stars can't hold their hydrogen envelopes. Radiation strips them bare, leaving rocky cores behind. Larger worlds survive, becoming gas-rich. It's a planetary Darwinism of light and gravity, where stars sculpt the very bodies orbiting them. Too small, you lose your atmosphere. Too large, you never stop being a gas giant. Just right, you get oceans, air, clouds, chemistry, and maybe life. Planetary systems are like symphonies played by gravity. Each world pulls on the others, tuning or breaking the rhythm. Some settle into elegant orbital resonances. One planet circles twice for every 3 orbits of another, their gravitational handshakes keeping peace. Others spiral into instability, worlds ejected, orbits stretched, collisions reigniting ancient violence. It's a reminder that the solar system's calm is not normal, it's luck. And stability is temporary. We live in a rare pause between catastrophes. Astronomers have catalogued some truly unhinged planets. WASP 76b rains molten iron. One side scorched to 2400 E, the other frozen in darkness. Iron vapor condenses, falls as metallic rain. Kepler 10b, a lava world where rock evaporates into vapor. A landscape of eternal sunrise and no mercy. Gliese 581d, possibly one of the first habitable zone worlds ever found, an early sign that Earth might not be unique. 55 Cancri E, a carbon planet, so rich in carbon that its crust may be diamond, a world glittering in darkness. These are not fantasies, they're data. Each one tells us that the universe's creativity doesn't stop at Earth's recipe. Around some of these planets may orbit exomoons, worlds the size of Earth, hiding in plain sight. They're difficult to detect, but simulations show they should exist. And some could be habitable even when their parent planet isn't. A super Jupiter with an Earth-sized moon in the habitable zone. That's a double world, one planet always filling the other's sky. Life could rise there, watching auroras arc across a horizon dominated by its gas giant. Imagine oceans pulled by colossal tides, continents breathing under perpetual moonlight. And if such a civilization looked up, they wouldn't see a moon. They'd see a world they orbit, glowing in colors Earth has never known. We're starting to decode the ingredients that make planets alive, or at least capable of life. 1. Starlight. Too much, you fry. Too little, you freeze. 2. Atmosphere. Needs to trap heat but not suffocate. 3. Liquid solvent, usually water, but not always. Methane or ammonia could work. 4. Stability. Time for chemistry, to learn persistence. Where all 4 align, biology becomes inevitable. The chemistry of life doesn't care what planet it's on. It only cares about opportunity. The discovery of thousands of exoplanets means opportunity is everywhere. Every point of light in the sky could be a sun with its own story, its own geology, weather, tides, and horizons. Some burn clean and sterile. Some cradle oceans under alien skies. Some right now could have civilizations looking back, wondering if their sky hides us. The stars aren't just stars anymore, they're addresses, and the mail is finally leaving Earth. Every discovery so far has led to this. For centuries, humans have looked to the night sky and wondered, are we alone? Now, for the first time in history, we're close enough to look for an answer, not with imagination, but with evidence. Not with messages or probes or radio beacons, but by reading the air of other worlds. Atmospheres, the cosmic mirrors. A planet's atmosphere is a biography written in light. When starlight passes through a planet's thin shell of gas, molecules absorb specific colors. They're chemical fingerprints. With a telescope spectrometer, we can read those fingerprints from dozens of light years away. Hydrogen, carbon dioxide, methane, oxygen, each tells a story. Some mean geology, others could mean biology. Our own atmosphere shouts life to the cosmos. Oxygen from plants, methane from decay, water vapor from oceans. If aliens aimed their telescopes at Earth, they would know something breathes here. Now, we're returning the gaze. The hunt for biosignatures. We call them biosignatures, chemical combinations that life naturally creates and that planets rarely fake. Oxygen and methane together are a big one. On most lifeless worlds, they destroy each other. So if we see both at once, something must be replenishing them. We also look for ozone, nitrous oxide, even phosphine, gases that on Earth come from living processes. Add to that temperature patterns, cloud behavior, and color shifts, and suddenly you're not just seeing a planet, you're reading its heartbeat. But the trick is knowing when nature is lying. False positives. Planets that pretend. Stars can fool us. Volcanoes can fill skies with methane. Ultraviolet light can rip water molecules apart and fake oxygen. Photochemistry can forge and destroy gases without a single cell involved. So astronomers don't chase a single signal anymore. No, they hunt patterns. A mixture that's too weird for geology alone. A balance that looks self-sustaining, as if the planet is regulating itself. If we ever see an atmosphere that behaves like Earth's in reverse, constantly breaking equilibrium, always alive, that's when the alarms will go off. Hycean worlds, life in a warm ocean sky. Among the newest suspects are Hycean worlds, hot ocean planets wrapped in hydrogen-rich atmospheres. They're larger than Earth, smaller than Neptune, and often orbit red dwarf stars. At first, they seemed too extreme, but models suggest the combination of heat, pressure, and chemistry might make them teeming with potential. These planets could host biochemical reactions in their upper atmospheres or beneath vast global oceans. Some might even keep liquid water despite surface temperatures above 100 degrees C, their dense atmospheres acting like pressure cookers for chemistry. If life can thrive in boiling acid vents on Earth, then a Hycean world might be an alien's idea of home. And the best part? These worlds are common. There could be billions in our galaxy alone. The Terminator Zone, twilight habitability. Next, imagine a tidally locked planet, one face scorched, the other frozen. For decades, scientists wrote these worlds off. Too hot on one side, too cold on the other. But then simulations revealed something incredible. Between the extremes lies a twilight strip, a narrow band of eternal sunset, where winds from day and night mix to create balance. Temperatures there might hover near liquid water levels. If any world deserves poetry, it's these. Planets with a ring of gold between black and white, where dusk never ends and civilizations might live under a forever sunset. Could life look like us? Probably not. Life elsewhere might not even use DNA. It could be silicon-based or live in methane lakes like on Titan. It might breathe hydrogen instead of oxygen or metabolize sulfur. Its biology could unfold in chemistry we haven't invented equations for yet, but evolution everywhere still bows to the same laws: energy, competition, adaptation. So even if alien life looks nothing like us, it will make sense. It will have structure, logic, purpose, because physics leaves no room for chaos to last. JWST, the telescope that sees time. Right now, the James Webb Space Telescope is turning that idea into data. With its gold mirrors, JWST can split starlight into astonishing detail, reading the gases of planets like K2-18b and TRAPPIST-1e, sniffing for the faintest traces of life. In 2023, it may have found methane and carbon dioxide on a Hycean world, and possibly, maybe, the molecule dimethyl sulfide, which on Earth comes only from life in the sea. It's not proof yet, but if it holds up, it would be the first time humanity has detected life across space. Think about that. Not in myth, not in speculation, but in data. Voice softens. Cinematic close. Every new exoplanet spectrum we collect is a conversation with the cosmos. A question whispered across light years: is anyone else breathing? We're not just searching for microbes or molecules. We're searching for context, for belonging, for proof that the universe knows how to do this trick more than once. And somewhere out there, in a dim star's twilight, life might already be looking up, asking the same question and finding the same answer. For as long as we've looked up, we've wondered what's out there. Now, we know. Thousands of worlds, each a possibility, a story, a mirror. The question is no longer, are there other planets? It's, when do we go? The first voyagers. Our first steps beyond the solar system have already begun, not with people, but with messages. Voyager 1 and 2 are still drifting outward, their golden records carrying greetings in 55 languages, images of life, sounds of thunder and laughter, a blueprint of who we were when we first dared to look beyond home. They're moving at 17 kilometers per second, yet even at that speed they'll take tens of thousands of years to reach the nearest star. We've left the cradle, but we're still crawling. The need for speed to reach another system within a human lifetime, we'd have to travel at 1/10 the speed of light, around 30,000 kilometers every second. No spacecraft today comes close. Even NASA's Parker Solar Probe, the fastest human-made object, peaks at about 690,000 km/h, less than 1/10% of light speed. So the next frontier isn't distance, it's velocity. The laser sail dream enter breakthrough starshot, a real project to launch gram-sized probes to Alpha Centauri. The idea, use ground-based lasers to push an ultra-thin reflective sail. No fuel, no rocket stages, just photons punching tiny ships to 20% light speed. At that velocity, the probes could reach our nearest star system in about 20 years. It's engineering on the edge of insanity, and yet it's the most plausible plan anyone has ever put on paper. When those sails launch, they'll carry our first real look at another sun, and maybe another Earth. What we'll see. Imagine the first image returned from a world orbiting Alpha Centauri. A faint blue dot wrapped in clouds, maybe continents, maybe oceans. A sunrise that's not ours. Even if no life is found, just seeing another habitable planet in detail would change what it means to be human, because exploration isn't about escaping Earth. It's about understanding that Earth is one of many, and that survival depends on learning from the rest. Telescopes as starships. Before we send ships, we'll send eyes. The next generation of telescopes, and the Nancy Grace Roman, Louvois, and Habeck's concepts, are designed to block the glare of stars and directly image Earth-like planets. They'll show us weather systems, color shifts, maybe even continents. They'll measure day lengths, track cloud patterns, and detect seasonal chemistry. It'll be like watching a living world orbiting another sun, a preview of a destination humanity might one day reach in person, the first interstellar generation. Maybe it won't be us. Maybe it'll be our grandchildren, born aboard colossal, slow-moving ships, floating ecosystems powered by fusion or antimatter, or technologies we haven't yet dared to name. They won't be explorers in the old sense. They'll be citizens of the void, a generation whose sky is an engine room and whose horizon is a memory of Earth. To them, the Milky Way won't be distant. It'll be home. Why we search? Finding life elsewhere won't make Earth less special. It'll make it more precious, because we'll finally see what's rare and what's universal. If life is common, we're part of a vast story. If it's rare, we're its only author. Either way, discovery gives meaning to the silence. We're not hunting aliens for spectacle. We're looking for context, for proof that life is not a fluke, that consciousness can bloom more than once in a universe that favors entropy. The cosmic mirror. In the end, every planet we find is a mirror turned outward, a reflection of what we could be, what we might become, or what we could lose. When we finally step onto another world, we won't just be explorers, we'll be witnesses to the universe realizing itself. The stars will no longer be distant. They will be places, addresses, and perhaps invitations. Closing narration, calm, reflective tone. We began this journey looking up at a sky full of lies, a sky that seemed empty, silent, still. Now we know better. The silence was an illusion, the stillness was motion, and the emptiness was filled with worlds. Alien worlds, beautiful, hostile, endless, each one proof that creation never stopped. It just moved beyond the range of our eyes. And now, finally, we're catching up. Like and subscribe to Skyward Space Quest for more explorations across the universe. Thanks for watching.